Hey guys, Dr. Brown here, and tonight we're working an integration problem, the integral of x plus 3 over the square root of minus x squared minus 2x plus 3 dx. So do you know our tools? UTI, PP, LCQ. That's a C. That becomes important. That's the one we're going to use here tonight. U sub, trig sub, integration by parts, partial fractions, power reduction, long division, completing the square method of quadratics. Okay, so let's think about using completing the square here. And then later we'll use trig sub. Those are the two tools we're going to use. Completing the square and trig sub. So I've taken, we need to do a little manipulation on the denominator. So I've written it here, minus x squared minus 2x plus 3. And I'm going to go through the method of completing the square. But first, I need to get that negative away from this. So it's minus the parentheses of x squared. Every sign will change, plus 2x. Now I'm going to plus the box, minus the same box, and this would be minus 3. Now I'm going to look at my video to make certain I didn't get off the edge there. Okay, good. All right, so you know we have the A term, B term, and C term. I'm going to put a parentheses about that. Okay. So we have b over 2 squared, right? That's how we figure out what goes in the box. So I have 2 over 2, which is 1. 1 squared is 1. So I added 1. I'm going to subtract 1. Okay. So what is that? How do I continue with that? Well, taking the square root of the outside terms here in this parentheses. So the square root of x squared is x, square root of 1 is 1, and then keep this sign. If it were a negative, I'd put a negative there. Since it's positive, put a positive, and that's what gets squared. Okay, so x plus 1 squared will give me x squared plus 2x plus 1. Now, minus 1 minus 3 is minus 4. Keep in mind, I have the negative outside of those brackets. So I'm going to distribute that negative to this point here, keep it on the other term. So negative, negative gives me a positive 4 minus x plus 1 squared. Okay, if you just look at that, you will have, and think about trig functions, that looks like a sine function, 1 minus sine squared. Okay, so hold that thought. All right, let's plug in the blanks here. What do we have? We have x plus 3 divided by the square root of 4 minus x plus 1 squared. Integrating that with respect to x. As I just mentioned, that looks like sine. So let's think about that for a moment. If I were to say, all right, a squared equals 4, a equals square root of that, which would be 2, x plus 1 equals a sine theta. And then if I take the derivative of that, dx equals a cosine theta d theta. Oh, by the way, since I have an x term here, I need to solve for that. So if I subtract 1 from both sides, I'm left with x equals a sine theta minus 1. All right, let's plug in the blanks again. I have the integral of x, which was a sine theta minus 1 plus 3 over Oh, well, let's keep going here. The square root of 4, which is a squared. A squared was 4. Minus x plus 1 squared. We said x plus 1 was a sine theta. If I square that, if that side gets squared, then I have a squared sine squared, which gives me a squared sine squared theta. And dx is a cosine theta d theta. So now we've gone from the x world into the theta world. Now I don't have any x terms left. Let me factor a square out of this. I'll just do that without moving anything. So if I factor a square out, I would have 1 minus sine squared times that a squared. That would give me a squared minus a squared sine squared that I had previously. Okay, the square root of a squared is a, so this a and that will cancel. 1 minus sine squared is cosine squared. The square root of cosine squared is cosine. So this and the cosine term cancel, which leaves me then with the integral of a sine theta, and 3 minus 1 is 2, so it's a sine theta plus 2, and I'm integrating that with respect to theta. So the integral of a sine theta d theta is a minus cosine theta, because you know the derivative of sine is cosine, so the integral is minus cosine theta. And then the integral of 2 d theta is 2 theta. So I'm going to flip these around. That's 2 theta minus a cosine theta. All right. I'm going to move that to the top. We have 2 theta minus a cosine theta. Let's draw our triangle. What did we have? We had, get rid of that squared term. We had x plus 1 equals a sine theta. So x plus 1 equals a sine theta. So if I solve that for sine theta equals x plus 1. I divide both sides by a. Sine theta equals x plus 1 over a. So if this is theta, the opposite side is x plus 1. The hypotenuse is a. We said a was 2. So this side would be a squared minus this side squared. So I have a squared, which is 4, minus x plus 1 squared. Now we worked that earlier. So 4 minus x plus 1 squared was what? This term here. So that equals minus x squared minus 2x plus 3. And if you don't believe me, just FOIL it out. So you'd get x plus 1 squared, or x plus 1, and 4 minus all of that. So that's 4 minus the parentheses of x squared. So 1x and 1x is 2x plus 1. So that's 4 minus x squared minus 2x minus 1. So now minus x squared minus 2x, 4 minus 1 is 3. So it gives me that term. All right, so theta is sine inverse of x plus 1 over a. A was 2. Let's write it here. So I have 2 times sine inverse x plus 1 over 2 minus a, which was 2, times cosine theta. Cosine is this term over the hypotenuse. So I have the square root of minus x squared minus 2x plus 3 over the hypotenuse, which was 2. So those terms cancel. And I'm left with that plus c. And that, my friend, is the integral of x plus 3 over the square root of minus x squared minus 2x plus 3. So the tools we used were completing the square, did that here, and then we saw the results, and we could use a trig substitute after that. Okay, all right, that's all for now. Keep studying, guys. Why are we doing this? I say it every video. We're trying to build a better tomorrow and do that through math. Okay, that's all for now. We'll talk to you next time. Thanks.